just when I felt I was getting somewhere with my revision 1 hardware, look what happens. This is the announcement on August the 8th, 2024 in the register. Raspberry Pi Pico 2 lands with a RISC-V cores. I'm probably not interested in the RISC-V cores, but the Pico 2 definitely brings some advantages that I'm going to be interested in. You've got double the on-chip memory to 520k, more onboard flash. It's got 2 of the ARM Cortex M33 cores, and importantly, from my point of view, it's got a hardware floating point unit rather than at the moment any DSP that I'm having to do. I'm using the software floating point emulation, so a hardware floating point unit is going to be a huge advantage. And this is Eben Upton here saying the extra performance, and particularly floating point and DSP performance, opens up a bunch of new applications both for hobbyists and professional users, he said of the Pico 2. So that's going to be pretty exciting. So I'm going to have to get myself one of these as soon as I possibly can. And here they are. So they're £1 more than the original Pico, but physically they look identical. That's one of the originals, and they're billed as being a drop-in replacement for them. So yeah, pretty excited by that. We've got extra processing power. You've got a better default clock speed, and the thing supposedly can run exactly the same software, so we'll have to see how that goes. Very few changes were required in order to get my code to compile for the Pico 2. There's a new SDK, so I cloned that over the top of the previous SDK, and apparently it's backwards compatible, so that shouldn't matter. And this is SDK version 2.1.0, and there's a new statement that you need to add to the cmakelists.txt file, and that's to set the Pico board type. So to compile for the previous Pico, you just call it Pico, and on the new one you just call it Pico 2. So very straightforward. One other change I had to make, I was hard coding an alarm number and an alarm IRQ, and this is for the external clock input, and that didn't work, and so I had to use this syntax to set the timer IRQ number, and that's something I should have done for the first version of the Pico anyway. For some reason I'd found a shortcut and I was doing that, but apart from that, it compiles and it runs. There is a slight issue when it comes to using the Pico 2 as a drop-in replacement for the Pico, the original Pico, and that's something that they're calling erratum E9, otherwise known as the GPIO bug, and it's caused much wailing and gnashing of teeth on Reddit and other user forums. People astonished that such a bug went unnoticed, but the reality is it's not a huge issue. All it is that the internal pull-down resistor is a bit too high a value, and it doesn't satisfactorily pull a port down to 0 volts if used as an input. So there are ways around it. One is don't use internal pull-down resistors. You could use an external pull-down resistor, and they say anything up to about 8.2k is sufficient, or you could change the hardware and use internal pull-up resistors, which is something I'll do, and it just affects a few of my switched ports where I'm currently using an internal pull-down resistor and then switching the port up to say 3.3 volts, and instead in my revision 2 hardware I'll change that to an internal pull-up resistor and switch the port down to ground. So it's not going to cause me any particular problems, but it does mean that the existing hardware as it stands doesn't work. In order to get a couple of my switches working, I've added external 4.7k resistors to pull the affected ports down to ground. So I've ended up with a couple of dead cockroaches around the board, but it's not a huge deal, and I'm going to be designing a revision 2 anyway, and at that point I'll change the ports to use the internal pull-up resistors and pull them down to ground externally with the switches, so it's not going to cause me any problems. I'm going to compare the speed of the Pico 2 with the Pico 1. This is running my PS RAM test, so writing 8 meg and reading 8 meg, so 3.5 seconds to write and 2.1 to read, and I'll make a note of those. And this is running the same test on the Pico 2. So write 8 meg in, what's that, 0.98 of a second, and read in 1.6. So let's make a note of those. And the results are in, and I'm getting a 2.4 times improvement in write speed and a 2.3 times improvement in read speed. It's not an entirely fair comparison because the Pico 2 has a higher base clock speed, and I found that I was able to overclock it further than I was the original Pico. But even so, 2.4 times improvement, I'll take that. That's pretty good. Pleased with that. In order to do a bit more testing, I want to get the thing mounted into a rack, so it's a bit easier for me to work on and to write software for. And so in order to do that, I need to mount it behind a front panel. And I bought a couple of these. They're about £4.50 from eBay. They're a 12 HP Euro rack panel, pre-drilled with mounting holes. So all I need to do is drill some holes in it and mount my board behind it. I'm going to mock up a front panel, so I've printed out the footprint layer from my board design, and I'm just going to, I haven't got a centre punch, so I'm just using a nail. I'm going to mark each position and drill some holes. Well, some pretty inexpert drilling, I have to say, but we've got it all mounted behind a front panel, so we can now see actually what it feels like to use in a rack. And here it is, mounted in a rack. So I've got some signals fed in, and I've got a USB cable coming out of the back so that I can interact with it, and yeah, that's going to be a whole lot of fun. But in the meantime, I need to really start working on my revision 2 hardware, because that's going to take a little while to come back from manufacture in China, and yeah, so I'm going to stop working on software at the moment. I'm going to do my revision 2 hardware, and then I can, whilst that's being manufactured, I can turn my attention to writing software, because hardware wise this all works. There's a few revisions I want to make, but I've got a decent test bed now where I can actually write some software for it.